In this final example, we'll work with the function, the relationship, the implicit relationship, y is equal e to the x cubed plus 8y. And we'll ask, what is the slope of the tangent line at the point -2, 1? Now, first, you should take x as being -2, put it in 1 being, and y being 1, put it into this equation, and you should see that if I put a -2 in for x, right, that would give me a -8. And if I put the 1 in for y, both here and here, that the relationship would hold true, right? Because, again, work it out. This would be -2 cubed gives me -8, plus 8 gives me 0, and e to the 0 is 1. On the left-hand side, we'd have 1. So it truly is equal, which means that -2, 1 is a point on our curve, whatever the curve looks like. I would have to put this into a graphing calculator because this is a very complex function, or again, complex relationship, and it would be quite difficult to just straightforward graph. Nonetheless, we can ask ourselves, at the point -2, 1, we know it's on the curve, so what is the equation of the tangent line? So we've got a point, and now we need to know, just like in the first example, what is dy dx equal to at the point -2, 1? What is this equal to? That will be our slope, right? Slope will be that value. So to get at dy dx, we need to use our implicit differentiation, which is just following our differential rules. So y is equal to the left-hand side. So the differential of the left-hand side, which is just dy, is equal to the differential of the right-hand side. So the differential of e to the x cubed plus 8y. So the left-hand side, we're done. But the right-hand side, we're going to have to use our exponent rule. So exponential rule says right here that if I have some base, in this case our base is e, and it's being raised to the u, which is some function, then we get ln of our base. In this case, ln of e is 1. So that'll be a 1. And then we just get au times the differential of whatever was up in the exponent. So putting that into play here, this is just equal to the whole expression, e to the x cubed plus 8y times the differential of whatever is up in the exponent. In this case, it's x cubed plus 8y. So that's just following our exponential rule. So continuing on, we get that dy is equal to e to the x cubed plus 8y. And now we're going to have to take our differential operator, our d, and follow our rules. And so the first rule we see, we're going to have to differentiate across addition. So that gives us that this is, I'm going to use parentheses so we are careful, because this thing is being multiplied with whatever is left here. So this is the differential of x cubed plus the differential of 8y. So dy is equal to e to the x cubed plus 8y times the quantity. All right, so taking a look here, we've got the power rule. So our power here, 3, comes down as our new coefficient, reduces by 1. Here we just have a constant rule. So the 8 moves past the differential. And so inside here we get 3x squared dx plus 8 dy. And now we know we're done differentiating. Why? Because if I look at my differential operator, it's hit the end. right? I've got a dy, I've got a dx, and I've got a dy. There's no further simplification that I can do. So now, because I want to know what dy dx is, I need to collect all my dy's together, collect all my dx's together, and then we'll do the appropriate division. So we've got to take this expression here before we can bring our dy's over. We've got to take this expression and distribute it across addition, right? So on the left-hand side, we get that dy is equal to, let's write it this way, 3x squared e to the x cubed plus 8y dx plus 8 e to the x cubed plus 8y dy. Now I'll bring all my dy's to one side, so easiest to just bring it to the left-hand side. Bringing that over, right? This is my coefficient in front of this dy. I've got a 1, right? There's a 1, we don't write it, but there's always a 1 in front of that coefficient. So subtracting this from both sides and bringing it over. So subtracting this from both sides, bringing it over, the left-hand side will become 1 minus 8 e to the x cubed plus 8y all times dy, and it equals, 3x squared e to the x cubed plus 8y all times dx. And so I'm going to divide both sides by dx. So I'm going to divide the right side by dx, which will cancel there. I'll divide the left side by dx, which will get me the expression I want, dy dx. And then to get rid of this coefficient, I'll divide both sides by 1 minus 8 e to the x cubed plus 8y. And I'll do the same on the right-hand side. 1 minus 8 e to the x cubed plus 8y. And so we finally get to the expression we're looking for, that dy dx, right? That's all that's left over on this side, because that will cancel with that. And on the right-hand side, my dx will cancel with that dx. And so on the right-hand side, I get 3x squared e to the x cubed plus 8y, all divided by 1 minus 8 e to the x cubed plus 8y. Okay? That's what dy dx is. And if I want, it's been a while, what are we trying to solve? We want the equation of this curve of the tangent line to this curve at the point negative 2, 1. So we said, okay, we need to find out what dy dx is, and in particular, we need to evaluate it at the point negative 2, 1. So we've solved for dy dx, and now we can evaluate it. So dy dx at the point negative 2, 1. So I've got to put my negative 2 in for x. So I'm going to put my negative 2 right here, as well as here, as well as there. And similarly for the 1, that's my value for y. So I'm going to have to put it here and put it up there. So this is equal to 3 times negative 2 squared e to the negative 2 cubed plus 8 times 1, all divided by 1 minus 8 e to the negative 2 cubed plus 8 times 1, which is equal to, so negative 2 squared is 4 times 3 is 12. E to the, so this is negative 2 cubed, giving me negative 8. And I'm going to add 8 to it, so the exponent there is a 0. All divided by 1 minus 8, and for the same exact reason, e to the 0. E to the 0 is 1, so this is 12 over minus 7. So that's my slope, and the question was, what is the equation of the tangent line? So finally putting everything together, it is y minus y naught, in this case is 1, is equal to slope, negative 12 over 7, times x minus x naught, which is minus 2, so it ends up being plus 2. And that's the equation of our tangent line to the curve of y is equal to e to the x cubed plus 8y at the point negative 2, 1.